Atoms can connect in different ways to build all kinds of substances. This video explores two major bonding styles, compares how they form, and shows how their different behaviors explain properties like melting point, conductivity, and solubility. Atoms form stable relationships by either transferring or sharing electrons. When electrons are transferred completely from one atom to another, charged ions appear, leading to an electrovalent or ionic bond. When atoms share electron pairs between them, they create covalent bonds that hold molecules together without forming separate ions. In ionic bonding, one atom donates an electron while another accepts it. The donor becomes a positively charged cation, and the receiver becomes a negatively charged anion. The strong electrostatic attraction between these opposite charges locks them together, creating an ionic compound such as common table salt. Covalent bonds form when atoms share electrons so that each achieves a more stable outer shell. Instead of forming separate ions, the atoms stay neutral but tightly linked by their shared electron pair. A molecule of chlorine gas, for example, consists of two chlorine atoms sharing electrons in a covalent bond. Ionic bonding usually builds vast crystal lattices, where each ion is surrounded by many oppositely charged neighbors, forming a repeating three-dimensional pattern. Covalent bonding, in contrast, creates discrete molecules, small clusters of atoms bonded together, that can move around independently as gases, liquids, or soft solids. Because ionic lattices are held together by strong attractions between many ions, they form hard, brittle solids with high melting and boiling points. Covalent substances, especially simple molecules, have much weaker forces between particles, so they are often gases or liquids at room temperature and melt or boil at relatively low temperatures. Ionic compounds conduct electricity when their ions are free to move, such as when melted or dissolved in water. The moving ions carry electric charge through the liquid. Covalent compounds typically contain neutral molecules, so even when dissolved, they lack mobile charged particles and generally do not conduct electrical current. Ionic compounds tend to dissolve well in water because water molecules stabilize the separated positive and negative ions. Covalent substances, especially nonpolar molecules, often prefer organic solvents like oil or alcohol. The rule of thumb is like dissolves like. Polar ionic materials mix with polar solvents, while nonpolar covalent materials dissolve in nonpolar solvents. Comparing the two bond types highlights clear patterns. Ionic bonding involves electron transfer, produces high melting solids, conducts when molten or in solution, and usually dissolves in water. Covalent bonding relies on electron sharing, yields low melting molecular substances, rarely conducts electricity, and more often dissolves in organic liquids than in water.